new topic, that is PERT and CPM. So the meaning of PERT is Project Evaluation and Review Technique. And the meaning of CPM is Critical Path Method. So the main object of PERT and CPM is same, only there are two different approach. For example, suppose we have given some project, so what are the critical activity and how to review the project so that all the critical activity should be given priority and all non-critical activities should be given second priority, and the given project should be completed within a time. So this is the main aim of PERT and CPM. These two are different techniques, but their aim is same. So we will see one by one. So PERT was invented by US Navy. PERT was invented by US Navy. This is in 19th century, and CPM by Walker. Sometimes this part come in objective, so who are the inventor? So PERT by US Navy, CPM by Walker. So first we will take PERT and then we will see CPM. Before that, let us see what are the difference between PERT and CPM. So first we will see difference between PERT and CPM, and then we will take PERT first, then CPM. The first difference is that PERT is event oriented, on the other hand CPM is activity oriented. This means a small event is given priority in case of PERT, while in CPM the full activity, one full activity which is a combination of event is given priority. So these two are, this is the first difference. So PERT is event oriented and CPM is activity oriented. This means when information regarding event are given, we perform PERT analysis, and when the information regarding different activities are given, CPM analysis is done. The second difference is that in PERT uncertainty is more than CPM, because the PERT depend on three time estimate, that is optimistic time estimate, pessimistic time estimate and most likely time estimate. Since the time estimates are more, therefore the probability statements come into picture, and therefore the uncertainty is more. On the other hand, CPM depend on only one time estimate, that is called optimum time estimate, and therefore the probabilistic statement is less. So this is the second difference. So in part, unsurety, probabilistic, statement is more than CPM. This is because part depends upon three time estimate. First is T naught, that is optimistic time estimate. TP, pessimistic time estimate, and TM, most likely time estimate. On the other hand, CPM depends on single time estimate, that is T naught, which is called optimum time. So, and the last difference is, in case of CPM, cost consideration is more, therefore the activity is always related to cost. On the other hand, this is not in case of part. So this is the third difference. So the third difference is cost consideration is more in CPM. This means the activity is always related to cost, and the same thing is not in part. So this is the difference. So now we will see the part. So there are some terminology which are used in part and CPM. So let us see some terminology. Used in part or CPM. So let us see. So first is project. Basically, project is the combination of interrelated activities which should be sequentially performed in order to do a particular work. So this is all the work should be done in sequence to complete the project in a given time. So it is the combination of interrelated activities which should be sequentially performed in order to do a particular work. Now the second is activity. Activity is a physically identified part of a project which consumes both time and resources such as man, machine, material, and the full project is broken in activity, and this is denoted by arrow. So it is the physically identified part of project which consume both time and other resources such as man, machine, material, etc. And activities is a small part of project. So the full project can be broken in activity. The activity is denoted by arrow. So if this is arrow, so this will be called as activity. This will be called as activity. This is activity. This is activity. And it is always labeled as number like A, B, C or 1, 2, 3, and the starting point is called as tail point and the ending point is head. So this is the starting point, this is called as tail. This is the ending point, this is called as head. Now next point is event or node. The starting and ending point of an activity is called event or node. For example, this is called event, this is called event, this is the starting event, this is the ending event. So the starting and ending point of an activity is called event. So for example, this is I, this is J, this is activity A. So this is event, one event. This is another event. This is tail node. This is head node. Since event is a point in time and does not consume any resources, so it can be labeled as a number within a circle. Now next point is, third point is path. Path is a continuous unbroken chain of activity from initial event to last event. So this is the, it is a continuous unbroken chain of an activity. Now we will see the rules for drawing the network. So there are certain rules which must be followed while drawing the network. Before that, let us see how the network look like. For example, this is we have drawn. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So this is one of the network, and this is the initial event. This is the final event. So this we can say this is one of the network. So network is nothing but a graphical representation of logical and sequential connected arrow. And there is initial event, there is ending event. So let us see the rules for drawing the network. So the first rule is that each activity should be represented by one and only one arrow. This does not, for example, this is one activity. Let us say this is activity A. So 2 to 3 is another activity. I cannot write A. This has to be represented by word B. For example, now if 2 to 4 again cannot be represented by A or B, it has to be represented by activity C. So all activity must be represented by one and only one arrow. So there should not be any repetition. So this is rule number 1. Each activity should be represented by one and only one arrow. There should not be any repetition of the activity. Then while drawing the network from left to right, arrow pointing in the opposite direction is not allowed. So this is my rule number 2. In a network, flowing from initial event to final event, arrow pointing in opposite direction is not allowed. For example, let us one part of network we have drawn. So this cannot move like this way. This has to move only this way. So this reverse path or moving in the reverse direction, this is not allowed. This part is not allowed. So always we have to move in forward direction. We cannot go to the backward direction. So this is one of the important points. This should be kept in mind. Now rule number 3. Activity always should be kept straight and not bent. So activities should be kept straight and not bend. For example, this is 1, 2. So activity should be drawn like this way. It is not that we have drawn like activity 1 to 2 So this bending part is not allowed. All activities should be straight. So only straight activities are allowed. So now rule number 4. Angle between the arrow should be as large as possible. Angle between the arrows should be as large as possible. Rule number 5. If required, dummy activities should be used. If required, dummy activities should be used. Rule number 6. An activity which has only determined the precedence, the precedence relationship can be maintained using dummy activities. So rule number 6 talks about only definition of dummy activities. That is, dummy activity is the activity which determine the dependency of one activity over the other and does not consume any time. So this dummy activity determines the precedence of one activity over the other and does not consume any time. Now rule number 7. Dummies are generally represented by dotted line. So dummy activities are represented by dotted lines. So if anywhere such type of activity is there, this will be called as dummy activity. So for example, two activities cannot have same starting and ending point. So such type of confusion can be avoided through dummy activities. So for example, this is I, this is J, this we have, so like this way. So two activities A and B both are having same starting and ending point, so this is not possible. So for this, use dummy activities. So for this this will be activity A, this is I, this is J, this will be B, here we will draw. So this will be dummy activity and then we can proceed to other activities. So this is called dummy activity. And the last rule is that which is called rule number 8. Each network can have only one starting event and one ending event. So each network can have only one starting event and one ending event. So these are the rules which should be followed while drawing a network. Now, how to number the given network? For this, we will follow the Fulkerson rule. So, different events are drawn like 1, 2, 3. So suppose this is, we have given some activities. So the starting event is labeled as number 1. So this is the drawing numbering the network. For this we use full cursor rules. So first the starting event is numbered as 1, and then the rest are 2, 3, 4 like this way. So this will write at 2, this will write at 3, this will write at 4. This I cannot write at 4, this I cannot write at 4, because this event will occur only when this 1 to 3 and 1 to 2 has occurred. Therefore this will be numbered after this and this. So this I can write as 3, this I can write as 3, or this I can write 2. So this may be 3, this may be 2. So after this event will occur, and when event 4 has occurred, or activities 2 to 4 has occurred, then and then this will occur. Therefore this will be labeled as 5. So 4 to 5 and 2 to 5 will give the event 5, and at the last event is drawn. So in this way we draw the network and we number. So this rule is called as full cursor rule.